Hello everyone, welcome to High Tech Study Plus. In today's video, we are going to start a new chapter from Class 9th Science. The name of the chapter is Motion. In today's video, we are going to understand some of the fundamental and important concepts of mechanics. It is the branch of physics which deals with the motion of objects. As we have mentioned the word motion, let us start first by understanding the word motion. We come across this word quite often in our everyday life, starting from birds flying, cars running on the road, planes flying in the sky, to the planets orbiting around the stars. These are all the examples of objects in motion. From our common experiences, we can simply explain the word motion by something which is moving. If we say it in better words, then a body is said to be in motion if the body changes its position with respect to its surrounding in a given time. Here, when we say something is changing position, we need to specify it with a reference point or origin. Suppose there is a ball and this ball is kicked by a person A. As shown, this person A, he kicks a ball. This implies that he is applying some force, due to which this ball starts moving. Now we say that the ball is in motion. Previously it was at rest, now it is in motion. Let us understand the reference point with the help of a concept that we have already come across in our mathematics books: motion along a straight line. We understand this concept by an example. Let us consider a number line as shown, and let each and every point in this number line represent distance in meters. Let us consider that there are two friends A and B. Initially, let us consider that B was also at the point X. A and B both were standing at point X, and after some time B starts moving from point X. A stands there with a stopwatch and records the time taken by B to reach the position Y. Let this be 10 seconds. In this interval, B is in motion whereas A is at rest, as we can clearly know. To say that B is in motion and A is at rest, we need to specify the reference point or origin. A is at rest, but with respect to what? In this case, the reference point is the point X. This is a reference point of choice. Now we come to know that A is at rest. Why? Because it is not changing its position from one point to another in a given time. So a body is said to be at rest if it does not change its position with respect to its surrounding in a given time. In the time interval of 10 seconds, we say that A is in rest but B is in motion. From the above example, we not only understand the concept of motion but also the concept of rest. Next, we come to a very important topic, the measurement of motion. First is the concept of distance and displacement. We have learned that to specify motion, we need to measure the change in position and change in time. That is, to measure change in position, we need to specify the distance covered or the path length. Let us consider the example of an object. Let this object that we are considering be a car. Let us consider the example for this. Consider a car which starts its journey from O, and let A, B and C represent the position of the car at different instants. First, the object moves through C and B and reaches A, and then it moves back along the same path and reaches the point C. Let the arrow marks denote the direction in which the car is moving. Now from here we can note that the total path length or the distance covered by the car is OA plus OC, which is equal to 25 km plus 15 km, which is equal to 40 km. Distance refers to the total length of the path traversed by the body, whereas displacement is the shortest path between the initial and final point. Clearly we can see that the body goes from O to A and then comes to C. So the shortest path covered by the body between initial and final position is nothing but the length OC. So the displacement of the car is OC, which is equal to 10 km. From this, let us discuss the difference between distance and displacement. Distance refers to the actual path length covered between the final and initial positions. So the actual path length between the final and initial position or the initial and final point is known as distance. Displacement is the shortest straight line path between the initial and final position. Distance is a scalar quantity, whereas displacement is a vector quantity. Scalar quantity is a quantity that has magnitude only. Vector quantity is a quantity that has both magnitude as well as a direction. Distance can never be 0 or negative, whereas displacement can be 0, negative, positive, and is always equal to or less than the distance travelled by the body. Now let us discuss about the various types of motion. Motion is divided into two types. One is uniform motion and the other is non-uniform motion. If the object covers equal distances in equal time interval, then it is said to be in uniform motion, and if the object covers non-uniform unequal distance in equal interval of time, then it is said to be in non-uniform motion. Measurement of rate of motion. To measure the change in position with time, we employ a quantity called speed. Speed is defined as the distance travelled by an object per unit time. The unit of speed is meter per second, centimeter per second. We use these all units, but the SI unit is meter per second. It is a scalar quantity. If we describe it mathematically, then we write it as V is equal to S by T, where S refers to the distance travelled by the body and T refers to the time taken to travel that distance. From this concept, we come to another concept, that is average speed. In most cases, objects move with non-uniform motion. In such cases, we employ the concept of average speed. Average speed is equal to the total distance travelled by the total time taken. Then let us discuss about velocity. We can say that speed plus direction is equal to velocity. When we consider not only the change in position of the object with respect to origin in a given time interval, but also the direction of change, then we employ another quantity known as velocity. Velocity is the rate of change in position in a definite direction. So V is equal to displacement by time taken for displacement mathematically. Velocity is a vector quantity, that is, it has magnitude as well as direction. Average velocity. In major cases of everyday life, velocity changes at a uniform rate. Then we use the concept of average velocity as initial velocity plus final velocity by 2. Here V refers to velocity. So V average can be written as VAV is equal to U plus V by 2. Now let us consider the difference between speed and velocity. Speed is the rate at which a body covers a certain distance, whereas velocity is the rate at which an object changes its position but in a certain direction. Direction differentiates velocity from speed. Speed is a scalar quantity, velocity is a vector quantity. Speed can't be 0 or negative, just like distance, whereas velocity can be 0, negative or positive. Speed counts even if the object changes the direction, but velocity changes if the object changes direction. Speed may or may not be equal to velocity, but an object may possess different velocities while having the same speed. If we consider the change in direction, then the velocity changes. So, an object possesses different velocities but same speed when it changes its direction rapidly. Next, we come to the concept of acceleration. In everyday situation, we generally come across changing velocities. For example, let us consider a bike that attains a velocity of 6 meter per second in 30 seconds, then applies a brake such that the velocity comes down to 4 meter per second in the next 5 seconds. In this case, let us first subtract the initial velocity from the final velocity, that is 4 minus 6, and the time in which this velocity has changed in 5 seconds. So, let us divide it by 5, which is equal to minus 2 by 5, which is equal to minus 0.4 meter per second square. Minus sign suggests that there is deceleration, that is the body has applied brakes and it is coming towards rest, or it has slowed down its speed. So acceleration is defined as the rate of change of velocity. The SI unit of acceleration is meter per second square, equal to final velocity minus initial velocity by time taken for change in velocity. So A can be written as V minus U by delta t, where delta t is nothing but the change in time. Acceleration can be also divided into two types: uniform acceleration and non-uniform acceleration. Acceleration is said to be uniform if the velocity changes at an equal rate, and if the velocity changes unequally with time, then we say that the body is in non-uniform acceleration. With this, we end today's class. Thank you. Hope you find this video helpful. Do like, share and subscribe our channel. For more such videos, stay tuned. Like, share and subscribe our channel.